something like this. So the encrypted password is removed and we just have an X over here. Every other information is still over here. And the encrypted password is still stored in another file called the shadow file. So it is in the same etc folder, but it is stored in the shadow file. Okay? So we'll come back to that later. So how is this password generated? So that's what we're going to see now. Encrypted password. Unix requires user password should be at least 8 characters long. If it's more than 8 characters, they are truncated. If it's less than 8 characters, you append what you call the 0 bits to make it like 56 bits. Why 56 bits? Because you need 8 ASCII characters to be part of your password, and the user passwords are printable passwords, right? You can really type whatever you want as a password. So the printable characters have ASCII values less than 128, which is like less than equal to 127. So you can just use 7 bits, okay, to represent these printable characters. So each character can represent the 7 bits, so 8 times 7 is 56 bits. Okay, so user password is transformed to 56 bits. So if you say you have a password of just 6 characters, you will add sufficient number of zeros so that you can make it 56 bits. And this 56-bit password forms the key for what is called the DES algorithm. So we use the DES algorithm to encrypt that user password. Okay? So the way it works is, you know how DES works, right? It goes through 16 cycles and the key is fed to each cycle by going through a transformation and all those stuff, right? Remember how DES works. The plain text here is actually 64 bits of zeros. So this is the plain text. And you subject this to DES and the key is the 56-bit password. Okay? So you know this generates what? A 64-bit ciphertext, right? And you do this 25 times. DES itself involves 16 cycles. You repeat DES 25 times. So same thing, whatever you get out of it, again go through another DES using the same 56-bit password. Okay, so repeat this 25 times. So still what you get at the end, the 64-bit ciphertext. It's just like increasing the complexity, so doing it once you do it 25 times. So eventually you get a 64-bit block ciphertext, and you want to transform that to those printable characters again as ciphertext characters. So what you do is you append 2 more zeros, so eventually now you have 66 bits, 64 bits plus 2 more zeros is 66 bits. So divide that into 6-bit segments like this. If you divide 66 bits into 6-bit segments, how many segments you have? 11 segments, right? So each segment will have 6 bits. So something like this. So now what you do is you kind of shift them to the left and add a 0. So you have like something like this, 1 0 1 1 0 1. You shift them to the left and you make it add a 0. So now you have 7 bits. So for this 7 bits you find you can represent what? In ASCII, in decimal, and that's the corresponding ASCII character. Okay? So what you can do now eventually is transform each of those segments into a printable ASCII character by basically shifting to the left and adding a 0 to the right. So you get a 7-bit value, find the decimal equivalent of it, and the corresponding ASCII character is the printable character. So that's how you transform or represent the encrypted user password in that file. Okay? So all those characters over here are represented or are obtained through that kind of transformation. Okay? Here? Any question?
You said do it 25 times?
Yeah, you do the DES 25 times. So eventually still you get only 64-bit ciphertext, but you do that after going through DES 25 times. And once you get that final 64-bit ciphertext, you append two zeros to make it how many bits? 66 bits. And divide that 66 bits into 11 segments. Each segment has 6 bits. So 6 times 11 is 66. Okay? So then what you do? Do something like shifting to the left and adding a 0. And that is like now 7 bits. Okay? So now find the decimal equivalent of the 7 bits that gives you a printed ASCII character. Now, if you look at the file and you count really the number of characters over here that I told represent the password, you will actually come across 13 characters. So far we just said in what, 66 bits divided by 6 will have 11 segments and each segment is transformed to a character, right? So, which means there should be only 11 characters in the encrypted password. But here we have 13 characters. Okay? What happens is the first two of these 13 characters, so you have 13 characters, the first two of these 13 characters is actually not the encrypted password. The remaining portion is only your encrypted password.
Can you point exactly like where you're talking about? Like you saying 13, like where?
This. If you have something like for example, the Rachel, the first user over there, has EH5, something like this. Okay, so these are the 13 characters of this encrypted password. But out of these 13 characters, these 11 characters are the ones that really come out as the encrypted password, based on what we saw just now. Okay? The first two characters are called what is the salt value. Remember we talked about salting before to kind of mitigate or avoid, not avoid, you cannot really avoid, you can really reduce the chances of a dictionary attack. Okay? So the first two characters form the salt value for the password. And this is where, remember when we discussed about salting, I told two possibilities. You can list the salt publicly in the file, or you can make it kind of, you need not list that. Unix follows the approach of publicly listing the salt value for the user. Okay? So how you kind of get EH, how it represents the salt. Unix uses a 12-bit salt value. Okay? So again I said, these characters really are transformed from that is a printable ASCII character, right? So printable ASCII characters are transformed from what? From that 0 and then the 6 bits to the left, isn't it? So these 6 bits of this first character and another 6 bits of the second character form 12 bits. Okay? So 12 bits means the decimal you can go up to 0 to 2 to the 12 minus 1. So 2 to the 12 minus 1 is 1495. So in decimal the salt value can be from anything from 0 to 1495. With 12 bits you can represent only these integers. Okay? And once you get those numbers, right, so generate a random number basically. So when you create a user account, administrator runs the sorting algorithm and generates a random number at the time of creating the account. So let's say I generate 3000 as the random number. The random number will always be between 0 to 1495. Okay? So represent this 30,000 as a 12-bit value. Or anything less than 4096 can represent as a 12-bit integer, binary, right? So represent 30,000, 3000 as a 12-bit binary value. So you get that 12-bit binary value for 30,000, break it into 6 bits. Once you have the 6 bits each, do that thing I showed. What? Shift that bit to the left and add a 0. So this is one 6-bit value, another 6-bit value, together making 12 bits. So each 6 bits go through this process and you get a printable ASCII character. So that's how you get those two characters representing the salt. Is that clear? Okay?
Where do you get 3,000?
The 3000 is a random
Yes,
number generated at the time of creating user account.
Mhm.
So each user gets a salt value at the time of account creation. Okay? So even if two users end up with the same password, right, the 13-bit value will be different. Why? What? Because of the salt. Okay? So even though two users choose the same password, right, their 11-bit, this portion will be the same, but the salt value will be different. Okay? Actually, the salt value is used as part of the DES, so I don't want to go to the details. So eventually, the whole 13-bit password will be different. Okay? And how it is made different, even though they choose the same password to start with, the salt value is really fed into the DES algorithm. And that makes it really different, because unless you create the two accounts at the same time and they get the same salt value and the same password, then their encrypted password will be the same. But you don't really have situation where two user accounts are created at the same time, the same administrator, and both people should use such the same password. That's very rare, right? So this way you can say that two people have selected the same password still end up with a different encrypted password value. Yes.
This says file is public.
This file, yes. But with the current Linux